So we've already talked about what happens when we're adding fractions with denominators that are the same. Let's look at some examples though, with what happens when the denominators that we're adding are different. So in this case, we're adding together 1/3 and 1/6. Now, one thing I know here is I know that 1/3 is bigger than 1/6. The reason I know that is because my denominator here is smaller. My denominator is smaller and my numerators are both 1. So these are two unit fractions. I know then that because my denominator in the 1/3 is smaller, I have bigger pieces. It's split into fewer pieces. I also know that because 6 is double 1/3, 1/6 is actually half of 1/3. 1/6 is like taking a third and splitting it into two equal parts. Now, when I have denominators that are different, we have different size pieces, so we have to think of this in pieces that are the same size. One way we can do that is by making common denominators. That means the same denominators. Now, one strategy we can use to do this is we can look at our two denominators, and we're looking for something called the least common multiple. That means what is the multiple that is the smallest that these two numbers have in common. Now, remember when we're thinking of multiples, we're just thinking of counting by that number. So 3, 6, and we're looking for a multiple that's the same. So in this case, I find that 6 is going to be that multiple. Now, I already have 1/6, so that number is already good as 1/6. What I'm going to do is I'm going to think of thirds in terms of sixth pieces. So how many sixths would it take to make the same thing as 1/3? Well, one thing I know is that if I think of how do I get from 3 to 6, I know I multiply by 2. So I'm going to do the same thing on the top here. Whatever I do to the numerator or the denominator, I must also do to the numerator. 2 times 1 is 2. Now, remember before we said that 1/3 is double 1/6, or 1/6 is half of 2/3. So it's going to be double the amount. 1/3 is the same as 2/6. Now, at this point, I know that 2/6 plus 1/6 is equal to 3/6. I have 2 of these sixth pieces. I have another 1 of these sixth pieces. Altogether, I have 3 of these sixth pieces. Now, we can go further here. We can do something called simplifying, because we also know that 3/6 is the same thing as 1/2. 3 is half of 6. One way we could find that is we could divide the top and the bottom by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So we get that if we added 1/3 plus 2/6, we would get 1/2. Let's look at another example. So in this example, we are adding 2/3 and 5/12ths. You'll notice in this example, the denominators are different, but so are the numerators. The numerators are no longer 1, but we have a 2 and a 5 in the numerator. Now, the first thing that I notice is that when I'm looking at this fraction 2/3, I notice that this fraction only needs one more third in order to get to a whole. So if I'm adding something that is bigger than a third, then I know that it's going to be more than a whole. So it's kind of tough for us to tell maybe now. Is 5/12ths bigger than a third? We can find that out later. And we can tell whether it's going to be bigger than a whole. That's something I always think about. The first thing I'm going to do is look for my common denominator, and you'll get better at finding your common denominator over time. And maybe some of these you'll just be able to look at them and find your common denominator. My common denominator here is going to be 12. Again, notice the 5/12ths is already in terms of twelfths. So I'm just going to deal with the 2/3 here. Just for reference, a 12th is like taking a third and splitting it into 4 parts. So a 12th is actually a fourth of a third, which is a much smaller piece. So because of that, I am going to multiply 3 by 4 to get 12. Do the same to the top here. And I get that 2/3 is the same thing as 8/12ths. So at this point, I'm just going to add 8/12ths plus 5 more of these 12ths, which is going to give me a grand total here of 8 plus 5, 13 of these 12ths. Now, we know from our working with fractions that 12/12ths is equal to 1 whole. Our denominator tells us that. Our denominator tells us that it takes 12 pieces. Now, in this case, we have 13/12. That means we have a whole plus 1 extra piece. Well, how big is that 1 extra piece? Well, it's a 12th. So I'm going to say that my grand total there, and let me write that again because that was a little poorly written, 1 and 1/12. 13/12 is 1/12 more than being a whole. Now, back to what I was saying in the beginning. I was saying we knew that 2/3 only needed one more third in order to be a whole. And if I look at this fraction 5/12, the reason I could have known this was going to be more than a whole is because 5/12 is more than a third. A third in twelfths would be 4/12. So that's 1 extra 12th. So that was like a third plus an extra 12th. So that's where that 1 extra 12th comes from in the end. All right, let's look at one more example. In this case, we have whole numbers and fractions with it. These are called mixed numbers when we have a whole number and a fraction together. Now, this actually works the exact same way. We can treat the fractions separately than we treat the whole numbers. One thing I do like to do here, though, is to estimate. First off, I know that 1 and 2/3, if I'm thinking how big that number is, I know that 1 and 2/3 is close to being 2 wholes. And I know that 2 and 3/4 is close to being 3 wholes. So if I add those together, I'm going to say my answer is going to be somewhere in the ballpark of 5. Not exactly 5. It's going to be actually smaller than 5 because we rounded both of these numbers up. But it's going to be somewhere in that ballpark. Now, when I add these two pieces together, 1 and 2/3 and 2 and 3/4, again, I'm going to look at my two denominators, 3 and 4, and I am going to find a common denominator. In this case, it is going to be 12. Now, notice neither of these pieces are currently in 12ths, so I am going to have to make them both into 12ths. What I always do is just start off writing it like this. So I know that I'm changing both of those into 12ths. Again, a 12th is a fourth of a third, so I'm going to multiply by 4. 3 times 4 is 12. Do the same to the top. You get 2/3 is 8/12. That's the same fraction as before. And a 12th is a third of a fourth, so I'm going to multiply by 3. 3 times 4 is 12. 3 times 3 is 9. Now, what I always like to do is just rewrite that problem. So I know that 2/3 is the same as 8/12. So I'm going to write 1 and 8/12 plus 2 and 3/4 is the same as 9/12. So I have 1 and 8/12 plus 2 and 9/12. I always first add together the whole numbers. 2 plus 1 gives me 3. And then I always go back and add together the fractions. I have 8 of these 12 pieces and 9 more of these 12 pieces. 8 plus 9 gives me a total of 17 of these 12 pieces. Now, again, I know right up here that 12/12 is equal to 1 whole. So in this case, I have extra wholes. Now, one thing we got to think about doing here is if I know I have 17/12, that's more than a whole. I already have 3 wholes. Altogether, then, I'm going to have 4 wholes because I'm adding extra pieces in. And then I know because 12/12 is equal to a whole, if I take 17 pieces minus those 12, I'm going to have 5 extra 12ths. So my answer will be 4 and 5/12, which is just a little bit smaller than 4 1/2. Because remember, 4 and 6/12 would be equal to 1/2. Now, these strategies can be used to add together any fractions, any 2 or 3 fractions, finding your common denominator first, and then thinking about what does your answer look like? Do I have an improper fraction, and how can I deal with that if I have an extra whole in my answer? So use these strategies to add together fractions and see if they work for you.